Hey, what's up, Moralis community? Welcome to another Moralis Blueprint. This week, we are going to talk about upgradable smart contracts. One of the best qualities we love about the blockchain is that the blockchain is immutable. It means once a transaction goes by, there is no way anyone can change or manipulate the information and the values of that transaction. But what happens with the smart contracts? Well, if you deploy a smart contract and sometime later you want to add more functionalities, or even more important, fix some bugs, well, you are doomed, because there is no way you can change the logic inside your smart contract. That's why upgradable smart contracts were invented. This is a way for you to deploy different versions of your smart contracts, but keep your users interacting with just one address. So, on this blueprint, we are going to start learning all the basics of what upgradable smart contracts are. Then, we are going to deploy two really simple smart contracts just to understand the difference between version 1 and version 2, and also understanding what the proxy pattern is. Afterwards, using all that knowledge, we are going to build a fully functional crowdfunding platform on which you are going to be able to create new proposals to get funding for crypto projects, connecting, of course, to Moralis APIs. And if the functionalities of the version 1 are not enough, we are going to be always able to deploy a new version using our proxy pattern. What's up YouTube, my name is Vasily, your Web3 instructor from Latin America, Ecuador. I've been building on the space since 2020 with cool crypto projects. In my free time I really enjoy singing and playing the guitar, and if the time is good, I like to go out and take some meditations. But enough about me, let's go back to the video and start building. Let's start by understanding what upgradable smart contracts are. As we already know, the blockchain is immutable, but immutability has its problems. First of all, you can correct mistakes. It means that once you deploy your contract, if you have any bug or any risk vulnerability inside of it, well, sorry but you are doomed, because there is no way you can correct that. Second, you cannot add new features. Maybe your dapp will have some needs today, but 1 year from now, you will need to add more features to your dapp. And again, you are not going to be able to add any new logic to your smart contract. And also, if you want to keep pushing different versions of your smart contract, well, the address of that smart contract is going to change, and you will have to convince all your potential users to move from the address 1 to the address 2. So as you can see, besides immutability is a great feature of the blockchain to prevent manipulation, it has its own dark side. Fortunately, experienced smart contract developers created a solution, and there are upgradable smart contracts. Now, there is a misunderstanding between what update means and what upgrade means. In software development, these two terms might be used frequently together or even as synonymous, but on this case, in the smart contract context, they have different meanings. So let's understand what update means on this context. Here we have the same contract, contract A, and this contract has a function called update number, which is going to just change the variable number to the new input variable. So here we have the number which is going to start at 0, and let's suppose we call this function and now the variable is updated to the number 42. So on the context, updating here means that we are just changing the value of the parameters inside of our smart contract, but we cannot upgrade this. Upgrade would mean that we are going to change the logic inside the update number function, and instead of just setting up the number to a new value, we might add a new logic. So we can update the smart contract, but we cannot upgrade it. The first one is the social convention. As I already mentioned, you can create different versions of your smart contract. In this case, contract A and contract B. Both of these are going to have different contract addresses. So if your dapp is already deployed, well, you have to convince the users inside your dapp to stop using the contract A and start using the contract B. And this has a lot of problems because let's say your dapp is already indexed on another pages, let's say on an exchange like SushiSwap. So you have to convince that exchange to start using the contract address B instead of the contract address A. And also you have to move all the information. Let's suppose you have here on contract A a lot of information such as balances, users, and a lot of transactions. Well, you will have to pass through the tedious process to take all the information from contract A and migrate it to contract B. And as you already might note, this solution is far from optimal. So there is another approach called proxy pattern, which has the delegate call. We are going to have just one contract to rule them all. The function calls are delegated to a new contract called proxy, and your users will always interact with the same address. So your architecture is going to look something like this. Your users will interact with the proxy contract, which is going to have just one address always. There is going to be a proxy admin, which is going to govern and control this proxy contract. Remember, if you want to keep your dapp decentralized, be sure that this proxy admin is managed by a DAO and not by just one wallet address. And then the proxy address is going to delegate the call of the functions to each version. So you can have version 1, version 2, and version 3, but your users will always keep interacting just with the proxy contract. And this has a big advantage, because if you want to update the value of a variable, as I showed you before, let's suppose the contract B has this function called setNewValue, which is going to change that value. Traditionally, the value could be stored on the contract B, but using the proxy pattern, we are going to call all the logic of the contract B inside of contract A. So the stored value is not going to be on the contract B, but on the contract A, being the contract A the proxy contract. So all the stored variables are going to remain on the proxy contract and not on the implementation contract. So on this example, we have two ERC721 contracts, which means are NFTs. And if you mint 10 NFTs on this contract, well, they are going to be stored on the proxy contract. Once you deploy the second iteration of your NFT contract, you are going to keep those 10 NFTs and you can start minting new ones, which are going to be again added to the proxy contract. So this logic works thanks to a function called delegate call. So you call the mint function through the proxy address, and the proxy is going to delegate the call of that function to the actual implementation contract. But the stored value is going to remain inside the proxy. In this context, we have different actors here. First, we have the user, which is going to be the one interacting with your dapp. We have the proxy contract, which is going to point to the different implementations. We have the implementation contracts, and we have the proxy admin, which is going to determine the rules of the proxy. On today's tutorial, we are going to use the transparent proxy approach. This means that the admin is going to be able just to execute functions on the proxy admin contract, but will not be able to interact with the implementation ones, and the users are going to be able just to call the functions on the implementation contract, but will not have access to modify any proxy admin function. This means at the end that we are going to prevent function selector clashes. With that explanation, we are ready to start the coding section. We are going to create two really simple smart contracts in order to see the difference between version 1 and version 2, code the proxy contract and the proxy admin, and see how we can upgrade between those versions. On today's tutorial, we are using Brownie as our smart contract development framework. So on the contracts folder, let's create a new contract, which is going to be called box version 1.so. Let's declare the license and the solidity version. And this contract is going to be actually really simple. At the end, we are just going to have a value, and a function to get that value. And this is it. This contract is going to be only capable to get the value of this variable. And as you already might know, on Solidity, all the uint variables will start at 0. So let's suppose we deploy this contract, and we are going to always be able to get the value of this variable, but that's it. We are not going to be able to do anything else. Now, let's duplicate this, change this to box version 2, changing, of course, the contract name. And here on the second iteration of this contract, we are going to add the functionalities to set that value to something the message.sender requires. So now we have two different versions. One on which we are just going to be able to retrieve the value, which we know is going to be always 0, and the second version which will allow us to update that value to something we want. So you already understand that this contract has nothing to do with this contract. If we want to upgrade from this contract to this contract, traditionally we will have to just point to a different address for each implementation. But now let's create the upgradable proxy and its admin. Fortunately, we are not going to need to reinvent the wheel because OpenZeppelin already has all we need to create upgradable smart contract. OpenZeppelin standard provides us all we need to create the proxy, and this standard has all we need, like get the implementations, upgrade to a new version, get the admin, and all the things I explained you before. So let's use this standard to make our life as developers easier. Here on the official OpenZeppelin GitHub, on the proxy transparent path folder, we are going to have two contracts we need to copy. The proxy admin, which is going to administrate that proxy contract, and the transparent upgradable proxy, which is going to have all the logic we need, such as the upgrade to uncall. This is going to upgrade the implementation of the proxy and then call the function of the new implementation specified as data. This data is going to be the function on the implementation contract. In this case, let's suppose we want to call this setValue function. This setValue function is going to be passed as data on the proxy contract, and with this proxy contract we can iterate from one version to another. And we also have the opportunity to just upgrade the version. So I'm going to copy and paste this into my project. Let's here create a new folder called proxy. I'm going to create a new file called upgradeable proxy.sol and another one called proxyadmin.sol. And I'm just going to copy and paste from the GitHub. First the proxy admin, and as you can see here, I have some difference here using directly at OpenZeppelin, and if you go to the OpenZeppelin GitHub, you're going to see that the proxy admin, for example, is making the imports differently. I'm just adapting this to my own use case as I'm using Brownie. So I'm going to do the exact same for the upgradable proxy, copy all of the code, paste it over here. Just don't forget to change the contract name and also make the correct import from @OpenZeppelin, and this is it. The admin is complaining at me because it's not able to recognize the proxy, so I just have to close this, open it again, and now it's going to recognize that I already have the code over here. And this is it. We can now use this upgradable proxy and its admin to pass from version 1 to version 2 of these boxes. So let's do it. So let's deploy these contracts and see how we can go through the process of upgrading them. Just in advance, I have here this script called helpful scripts with some utilities such as selecting the correct account we need to use depending on the network we are working with, function code encode function data. Remember, we need to pass the function we want to execute on the proxy as a data parameter, and this is how we are going to encode that data, and a function called upgrade, because we can have an initializer on the proxy contract, and this is going to act based on the context. If we have or not the initializer, we are going to just go and execute the function upgrade or the function upgrade and call, which again, both functions come from the upgradable proxy contract. And if we have upgrade to uncall, it means we are going to upgrade and call the function, or we can just upgrade it right away. Remember, all of these functionalities and utilities are going to be on the code description. With that said, let's create a new script over here, which is going to be used to deploy the box. So deploy box.py. First, we need to add some imports from Brownie, the box version 1, upgradable proxy, the proxy admin, and we are going to import the config, the network, and the contract functionality as well. Then we need to import from scripts.helpful scripts that get account functionality, and also the encode function data. Now we can use a main function, def main, and we are going to say account going to be equal to get account. We are going to say print to the active network. In this case, we are going to use the goerli testnet. Let's declare the box variable. So box is going to be equal to box version 1 deploy from account. And as we want to verify this, let's use publish source and get the verification from the config file on the Brownie config. Here on the Brownie config for the goerli network, we are setting up the verification to true. Just remember, we need to add here a .hemp file, which needs to be populated with our Infura project ID or private key for the wallet, and of course the etherscan token API key in order to verify the contract. After deploying the box, we can deploy the proxy admin. So proxy admin equals to proxy admin.deploy. Again, we are going to do it from account, and we are going to be sure we are verifying that contract. This proxy admin does not require any constructor parameters, so as easy as that, we have a way to deploy the box and the proxy admin. Now we need to encode the initializer, so box encoded initializer function is going to be equal to encode function data, but this box contract is not going to have an initializer. By the way, if you don't know what this initializer means, so sometimes you will need to change the value of a variable right away you make the implementation, so you can encode that functionality and add it as an initializer. So once you upgrade, well, you are going to change right away the value of a variable. We are not going to do so here because again, we are using two really simple smart contracts. Now we can deploy the proxy, so proxy equals to upgradeable proxy.deploy, and this is going to actually take some parameters. First, we need to send the box.address, which is going to be the contract we are going to call the functions from. We need to declare the proxy admin address, of course, and we need to use that box encoded initializer function, which you already know is going to be empty. We are going to say we want to do this from the account with a gas limit, and again I want to verify this on etherscan, so let's say published source, getting it from the config. Now we can say print proxy deployed at the proxy address, and now we can declare that box contract, so proxy box is going to be equal contract from ABI. We know this is called box version 1, and instead of doing something like this, like box.address, we are going to refer not to the address of the box, but instead to the address of the proxy. And this is the magic of upgradable smart contracts. When we are going to interact to a version of a smart contract, we are going to get, of course, its name, its ABI, but the address we are going to interact with is going to be the proxy contract. and the information is going to be stored on the proxy contract regardless the version of the contract we are using. So remember, we have here on the box v2 a function called getValue. So we can go here and say print proxy box value. We use this proxy box dot is not retrieve, but instead get value. If everything goes well, we are going to be able to deploy all of this and afterwards get the value as 0. So let's try this out. Here on my terminal, I'm just going to run brownie, run scripts, deploy. And as I want to test this on the local network, I'm going to run this locally using Ganache. So let's hit enter. This is going to compile all. And as you can see here, we deploy all the contracts and we are getting the box value at 0. And again, remember, we are interacting with the contract logic inside box v1, but through the proxy address. So now, as we have this proxy, we can now upgrade to a version number 2. Let's deploy that box contract. So here on the imports, let's say box v2. Now we can say box version 2 is going to be equal to box.deploy from the account and the verification. And then we can call the upgrade transaction. So upgrade transaction is going to be equal to upgrade, and we are going to pass the account, the proxy, the box version 2, and the proxy admin contract going to be equal to the proxy admin. Now it's time for me to explain you where this upgrade functionality comes. Remember, on our helpful scripts over here, we have this, which is going to take the account, the proxy, the new implementation address, in this case is going to be the version 2 of the box, the proxy admin contract, which starts at none, and the initializer, which I already explained you, is if you want to change right the way the value of a variable we are not going to use. So if we have an admin and we have an initializer, we are going to encode the initializer and upgrade the contract. If we don't have an initializer, we are just going to upgrade. And if we don't have an admin, well, again, if we have an initializer, we are going to encode the function and upgrade, and otherwise we are just going to upgrade. All of this is based if we have or not an admin. In this case, we do have an admin, so we can just come here, import that function, upgrade, and now, as you already saw, we are sending over the account, the proxy, the new implementation, which is going to be box v2, and the proxy admin contract. We don't have any initializer, so we can continue. Let's say that we want to wait one block confirmation, so upgrade transaction.wait1. We are going to print a statement saying that the proxy upgraded to version 2. And now we can declare a proxy box version 2, which is going to be again a contract from ABI. And look at this. We have the new implementation box v2 with the box v2.abi. The ABIs are going to be different because here we just have the get value functionality, and here we have the set value functionality. So we are pointing to different ABIs and different contract names, but we are going to keep using the proxy address. So now we can say print proxy box value. We already know it's going to start at 0, but now as we have the implementation of the version 2, we can now create a new transaction. Transaction equals proxy box v2 dot set value, let's say 42 from the account. Let's wait until this transaction goes by, and now we can retrieve again that value, which now should change to 40. Let's try this out on the terminal. Let's clean this and run again the script, and voila, as you can see here, we started with the value at 0, both in the version 1 and version 2, and afterwards upgrading, we can now store a new value which is going to be 42. And remember, we are keep interacting just with the proxy address, regardless the API and regardless the implementation name. And as easy as that, you learned how to create upgradable smart contracts and iterate between versions. How cool is that? As you can see, the process was really simple and straightforward. But now let's try and create something actually useful. For this example, we are going to create a fully functional crowdfunding platform on which we are going to have missing functionalities on purpose, and we are going to see how we can upgrade that crowdfunding platform and keep interacting with the same contract address on the front end. Well, as we already know how the upgradable smart contract works, so let's get started creating our crowdfunding platform. So I'm going to just close everything else here on my project to have a clean space, and on the contracts file I'm going to create a new contract called crowdfunding version 1.sol. Let's create that smart contract. As always, let's declare the license and the solidity version, and let's declare the contract crowdfunding. We are going to start declaring a struct on which we are going to store all the information for each crowdfunding campaign. I'm going to just put it here. We are going to have an owner, a title, a description, a category, a target, which means how many ethereum is requested, a deadline, the amount collected, an image, the donators, the donations, and the campaign ID. It's going to be a really complete struct, and each campaign is going to have all this information. Now let's create a mapping. So let's say mapping, and it's going to be a mapping going to relate uint256 to a campaign, and it's going to be called campaigns. So we are going to use this uint using the campaign ID to get the actual campaign we want to get. Now we also need to know how many campaigns we have. So let's say number of campaigns is going to be equal to uint256 public number of campaigns, going to be equal to 0. Now we did a function to create a new campaign. So let's say function create campaign going to be something which is going to ask for a lot of parameters, such as the owner, the title, the description, the category, the target, the deadline, and the image. This image is going to be an IPFS image, and of course we are going to use Moralis endpoints to upload that image to IPFS. This is going to be a public function which is going to return a uint256. Inside of here we are going to have a new campaign which is going to live on the storage called campaign, and it's going to get the campaigns from this mapping. So each campaign is going to be related. So as the number of campaigns start at 0, we are going to assign the first campaign to this number. Then we have to just update this value in order for each campaign to be different. So first of all, we are going to require that the campaign.deadline must be greater than the block.timestamp. This is because we just want to accept campaigns which has a deadline in the future, and then we just have to assign all those values. So let's say over here that the campaign.owner is equal to the owner sent as parameter, the same for the title, description, etc, etc. And now here is complaining with me because I put here campaigns, which was misspelled. So that's it. We are setting up all this information for these campaigns, and afterwards we are adding 1 to the number of campaigns. So each time we create a new one, well, it's going to have a unique ID. And finally, we just have to return the number of campaigns minus 1. And as easy as that, we have a way to create a new campaign. Now we have another function to donate into that campaign. I'm just going to add it really fast over here. So it's going to receive a uint256 of the ID of that campaign. The amount we want to donate is going to come from the message.value. Again, we are going to get the campaigns from this mapping based on the ID, and we are going to push into that campaign the donators and the donation. We are going to send the funds, and if the funds are sent, well, we are going to add that to the total amount collected. And finally, I'm going to add some getters over here. The first one is going to be to get the number of campaigns, to get a specific campaign based on the ID, which again is going to return all the information of that campaign based on that mapping again, and another function which is going to get all the campaigns at once. Basically, it's going to loop through the campaigns mapping based on the number of campaigns. And as easy as that, we have a functional crowdfunding smart contract. So as we already have this, let's create a script to deploy this smart contract. To deploy this contract, we are going to go through the same process as we did on the box, so we can just do it very quickly. Let's create another script called deploy crowdfunding, make the imports. In this case, we want to import the crowdfunding contract. Let's import the account and encode function data from helpful scripts, and let's define the main function. So def main account is going to be again equal to account to get account. As you may already know, this process is going to be like exactly the same as this one, but instead of using the box contract, we are going to use the crowdfunding contract. We can do it that way because the crowdfunding contract does not get any parameters on the constructor, so we can just deploy it as we did with the box. So the funding contract is going to be equal to the crowdfunding version 1. Again, let's verify this if we are on a livenet. The proxy admin, the encoded function data is going to be for the initializer, which is going to be also empty. And then we are going to have the proxy, which is going to take the funding address, the proxy admin address, the initializer, and of course we are going to do it through the account. And as easy as that, we have this. So we can go back to the terminal, clean it, run brownie, run scripts, deploy crowdfunding. Let's check if this works locally. It does. So now we are ready to deploy this on a livenet. For today's tutorial, we are using the early test network. So let's put the flag network, go ahead. And as this is a livenet, we should wait until the transactions go by. On the meantime, I just added 2 different scripts. One just to test out. We are able to create a new campaign. You can always test on your local environment, and another to vote on an active proposal, again just for testing purposes. I did it this way as this contract is very simple, but remember, you should always create personalized testing on the test folder, both unit and integration tests. So after all the contracts were deployed on the early network, we are going to have something like this on our build folder. Here on deployments, we are going to have a map.json with all the addresses we are going to interact with, and of course the contract APIs for the early network, which in this case ID is 5. So as we already have the contracts, let's suppose we are a smart contract developer and we are ready to create our frontend. So I'm going to leave you on the video description a template for the frontend we are going to use. But in order to use this information, the APIs and the addresses, we need to send this to the frontend folder. So here on helpful scripts, you are going to find another function called update frontend, which is going to send the build folder and the brownie config.yaml to a folder called frontend, and we are going to be able to use that into our project. You might be wondering, okay, but we are not upgrading this contract yet, and it's on purpose. We are going to add the functionalities to the front end, and at the end we are going to find ourselves that we went through a lot just to discover that our smart contract has missing functionalities. But thanks to the upgradable proxy, we are going to be able to just deploy a new version and keep where we left. So let's get started with the frontend. So for this project, we have such a beautiful template like this one, on which we have a landing page with some information, the Moralis wizard, some cool animations, and for now a section to explore the projects. And as you can see here, there is no projects yet because this smart contract doesn't have any, and a form to add a new one. We also have a section for the project details, which it's going to keep us loading because we don't have projects yet, and a connect button for connect the wallet, which for now doesn't do anything. I also added 2 more sections, but they are just with Lorem Ipsum information because this is just for showcasing purposes. Let's focus first on connect our MetaMask wallet to the dapp. Inside of the Web3 folder, you are going to find a lot of hooks which for now are empty, and this is the functionalities I'm going to focus on during this tutorial, because I'm going to suppose you already know how to manage Next.js and React.js. So let's start with the use connect wallet. For that, we are going to use ether.js. Don't forget to run an npm install in order to install all the dependencies on the package.json, so we can start now. First of all, we are going to need use state from React, ethers from ethers.js, and we are using React Redux in order to have some global variables. In this case, it's going to be the signer, which must be available worldwide on the application. So let's create that. Export function use MetaMask state, and let's add some use state variables to check if the user is connected, the account, the signer, and this dispatch is related to the React Redux. Now inside this function, we can create function called connect to MetaMask, which is going to have an event, and inside of this we are going to send that event prevent default. This is just to prevent the default behavior for the button. Now we can use a try and catch statement, and here we are going to use ether.js to connect. So let's declare a provider. The provider is going to be equal to ethers providers, the window.ethereum, which is the one MetaMask uses. We are going to get the account for that provider, and we need to set up the signer, which is going to be the one who signs the transaction. It means the account. Then we can set up those variables, set is connected, set account, is set signer, and as I want the signer to be worldwide available using React Redux, we also are going to use that dispatch using the set account to set up the sign. So finally, on this hook, we can just return is connected, account signer, and connect to MetaMask. And as easy as that, we have our first hook to connect the wallet. For now, our web page doesn't do anything. If we click, we still don't have functionality. So now let's use this hook. Here on my page, I have a section called layouts, and here on layout, I have to import use MetaMask state, and with that we can declare some variables. So here inside of the layout, let's say const is connected, account signer connect to MetaMask equal to use MetaMask state. With that, we can just go back here on the header, because the connection button is on the header, and set those parameters. So we can just say is connected, account signer, and connect to MetaMask is going to be equal to the variables and functions we are going to get from the hook. So with that, this information is going to be sent to this header component, on which we have this button over here, and this header must take those parameters as the prompt, and this component is going to take those parameters as arguments. So instead of just having this button over here, let's make the button to change dynamically. If we are not connected, we are going to be able to connect the wallet using the connect to MetaMask function, which again is going to trigger this connect to MetaMask. And if we are already connected, well, we are going to disable that button, and we are just going to say that the user is already connected. Let's save this. So we can go back to the page, click on connect wallet. This is going to trigger our MetaMask. We can click on next, connect, and now we are connected. As easy as that, we have the connection we need. Now for the project side, we have here an empty section, and with a form to add a new campaign for the crowdfunding campaigns. So let's create a new hook to accomplish that. Here I have an empty hook called use create new proposal. So let's go through the important parts. First of all, we need to import ethers, and in order to interact to any smart contract, we need two things: the contract address and the contract API. As I already told you, that information is going to come from the build folder on our Brownie project. That's why I created that function on the helpful scripts called update frontend, and here I have a script which is going to call that functionality. So we can go to the terminal and run Brownie run scripts update front. Once this is done, we can see that we are going to have on the src folder a new folder called chain info with all that information, the map of the deployments, and of course the contract APIs under this contract folder. With that, we can make those imports properly. So I'm going to import the contract address we are going to interact with, which is going to come from the map.json. In this case, it's going to be the proxy address. And also I'm going to import the crowdfunding API, because we are going to interact with the proxy address, but using the API for the crowdfunding contract. Then let's declare that hook use create proposal. This is going to have another function inside of it called function create new proposal, which is going to take all the parameters the smart contract itself needs: the owner, the title, the description, the category, the target, the deadline, and the image. And inside of this, we can first of all instantiate the address of the proxy admin. So proxy contract is going to be contract addresses 5 for the early upgradable proxy, and we are going to take always the latest one on the index 0. Then we need to use that API, so the crowdfunding is going to be equal to the crowdfunding API. With those parts, we now can create a new instance of the crowdfunding project. So crowdfunding instance is going to be equal to new ethers contract. We are going to send over the proxy contract address, the crowdfunding API, and of course the sign. The signer is going to come as a parameter on the function. That's why on the use connect wallet we are setting up the signer using Redux in order for it to be able globally around the application. Now we can create a new transaction. So let's say const transaction is going to be equal to await crowdfunding transaction to create campaign, and we need to send over all the parameters that function needs. So let's say that we are going to set up the owner, the title, the description, the category, the target, the deadline, and the image. After that, we just need to wait until this finishes. So await transaction.wait. Let's wait until one block confirmation, and we have this nice function over here, but I'm going to grab this all into a try catch statement just in order to be sure everything went fine. So I'm going to take all of this and grab it into a try catch statement. Finally, we just have to return that function create new proposal. This function is going to be triggered in the component crowdfunding form I have over here. Here we are going to use that form and send over the information, but with some biases. The first one is, for example, that we are going to send this image over here as a base 64 string, and the reason is because we don't want to upload this into a server, but instead use IPFS, and for that we are going to use one of the Moralis endpoints to accomplish that. The deadline also should be a Unix timestamp, so we have a function over here to transform that to a Unix timestamp, and well, the category is just a select, and the description and the title are simple strings. So as I told you, we are going to need to use Moralis to upload that image to IPFS. So if you don't have a Moralis account yet, this is the part of the video for you to go to moralis.io, create your free account, which is good enough for basic petitions. If you're working with a big NFT collection or marketplace, step up your blockchain game with Moralis Pro. With twice the computing power and more requests, you can handle even the most demanding projects. Plus, enjoy unlimited daily records on your streams with automatic retries for a seamless experience. And with more replays and longer retention for your historic streams, you'll never miss a beat. Don't settle for basic, upgrade to Moralis Pro today and take your projects to the next level. So here on the documentation, under the EVM section for IPFS, we have the endpoint we need to interact with in order to update that information to IPFS. We can do it using different programming languages such as JavaScript, TypeScript, and Python. And Moralis provides us step by step all the things we need to execute this. As we already use Brownie with Python for the smart contract deployment, we are going to keep using Python for the backend to connect to this API. For this, we are going to have a Django project. So here on the backend folder, I have my Django project here, and in a file called services.py, I'm importing moralis.env to set my API key as an environment variable on this file over here called .env. Remember, you can get your API key here on your Moralis admin panel. So for that, let's check how this endpoint works. We can go back to the documentation. It says that we need an API key. We already have it. We need to specify the path for the image and also the content, which is that image but on a base 64 string. So we need to connect to the EVM API.ipfs and send the API key and the body. As easy as that. So we can even copy this, go back to the services.py and paste it over here. This import I already have it, and the API key I also already have it. So now we just need to replace this path and this content to something we are going to send as parameters. So in order to accomplish that, we need to transform this into a function. And with the magic of addition, we have that function ready. I created a new function called update image to IPFS, which is going to take the path and the image as parameters, call the Moralis endpoint, and return the result. With this script ready, we can now go to the project views. Here I have an empty endpoint called upload image, on which we are going to use that function. So I'm importing from .services the upload image to IPFS functionality, and also using JSON because JavaScript does not understand Python types, and we are going to need to send that information as a JSON. So inside of the views, I'm going to say if the request equals to method post, because if we check out the documentation, this is over here on the API reference, we see that this is a post request. So if the method is equal to post, let's say that the JSON data is equal to the request.body, so we can have separately the path and the content. Now we can just use that function we just created, upload image to IPFS, sending the path and the content, which is going to come from the frontend, and we need to return this as a JSON. So JSON result is going to be equal to json.dumps, and let's return a HTTP response. With that, we have all we need to send that petition to the API and return it to the front. Just don't forget on your URLs to add that view as a new path. So as all the backend is ready, we can run this using python manage.py run server. And on the front end, we can connect to that endpoint. So returning to the crowdfunding form, we have this button, which is going to be the type submit. It means here we have a handle submit functionality. And the first thing I added here is send image to IPFS. I created a new function here, which is going to use Axios to connect to that endpoint, upload image, and set the information, the path image with the image file name, and the image that, as I already told you, should be transformed into a base 64 string. After we send that information to IPFS, we are going to have that IPFS link, so we can set up the amount and the Unix deadline. Again, I'm just transforming this to something compatible to the smart contract, and then we can call that create new proposal. The owner is going to be designer.address, the title, the description, the category, the it amount, the Unix deadline, and the IPFS URL comes directly from the form. And of course, we need to send over the signer, which comes directly from MetaMask. So if everything is working properly, I can return to my web page, say here, put here some information. Let's upload an image like this one. And if we click on create, this should trigger a new transaction on MetaMask. Let's confirm this and wait until the transaction goes by. And oh no, the transaction failed. And ladies and gentlemen, this was on purpose, and the reason is because here on the smart contract, instead of using a greater, we should use a lesser. But wait, does it mean we have to ask our users to start interacting to a new contract address? Well, you already know that that is not correct. So let's keep this as major and let's upgrade this crowdfunding contract, fixing this bug, but again, our users are going to keep interacting with the same contract address. And as you can see, a simple symbol can ruin completely your workflow. So let's create a new version of this contract. Just Ctrl+C and Ctrl+V. Let's change this to version 2. This means we have to change also this to version 2, and let's correct that over here. This should be lesser. Let's save this, and now we can upgrade this. So using the same logic we used to upgrade the box, I'm going to take the instance for the crowdfunding version 2, use the proxy admin and upgradable proxy, the latest implementations, and upgrade it to the version number 2 using the upgrade functionality. So let's try to use this. Run your own scripts, upgrade funding, on the network URL. After the transaction finishes, well, our contract will be upgraded. And if we take a look to the build folder over here, we are going to have now a map.json including the crowdfunding version 1 and the crowdfunding version 2, but we are going to keep interacting with the same proxy admin. Of course, as we deployed a new crowdfunding version 2, it's wiser for us to execute again that brownie run scripts update frontend to send that information to the frontend as well. So here on my hook, the hook create new proposal, I can leave it as it is, and the only thing I have to change is the import. Instead of importing for crowdfunding version 1, I'm going to import from crowdfunding version 2. If everything works properly, that means we can return to our web page, and using the exact same form we used before, we can click on create. This is going to trigger again a new transaction. Let's confirm this, go back here and wait until this process finishes. And voila, this process has finished. And now the transaction went by properly. So thanks to upgrading the smart contract, we can continue interacting with the exact same contract address. So as this contract worked properly, so that means if we check the implementation contract and click on get campaigns, we are now going to get a tuple of the campaigns. So it means this worked properly. And if we return to the main page, voila, we are going to have those new campaigns. And you might be thinking, okay, we didn't create any hook to render those campaigns. Yeah, I was a little bit ahead, and in the meantime that transaction went by, I created this use get campaigns, which again is connecting to the proxy address. And look at this, I'm using actually the contract API for crowdfunding version 1. The reason is simple, because even though here on the contracts we have this difference between this major and this minus, both have the same function called get campaigns, so I can use the contract API for the version number 1. If I go back to the hook get campaigns and change this to version 2 and save this, is not going to matter. Let's return here to the web page. Let's go back to home, explore projects, and as you can see here, we are getting the exact same result. Now, in order to be able to donate to this campaign, well, we are going to need to create two more hooks. First of all, get campaign individually, because we have the other function to get all the campaigns, but remember we have this one which is going to return just one based on the ID. Again, I'm importing this. It doesn't matter if I use version 1 or version 2 for the API, because that functions are similar. Declare the provider, declare the contract instance, call that functionality get campaign based on the ID, and the ID is something we are going to get from this page. This all is going to be useful over here on this component called project details. This project details is going to take that ID, call that hook get campaign to render all that information and show all the information over here, including a button allowing to donate. This donate button is connected to another hook called use donate to proposal, which again takes the contract API. It doesn't matter here if we use version 1 or version 2 in this case, because we are going to keep interacting with the same contract address, and calls that function donate to campaign, sending over the value. So let's try if everything works out. Let's go back here, click on this, and if you are wondering why I have two campaigns exactly the same, well, the reason is because I triggered that smart contract function twice just for testing. So let's click here. This is going to render the information. It was pledged 1 Ethereum. For now it has 0 backers and it has 7 days left. So let's, for example, donate 0.1 Ethereum, click on donate now. This is going to trigger another transaction, sending that value. Let's confirm this. Let's wait until this finishes. Well, this process finishes properly. If we reload this page, this is going to be updated automatically. We are going to have the amount recounted, which is going to be the 10% because we pledged just 1, the number of backers, and the date is going to be as same as before. At the end, I didn't want to get too deep into how to create React hooks, because I'm supposing that you already know how to use React.js, but I wanted to show you that even we did a mistake, a little mistake that anyone could make, we didn't have to ask all our users to start using an entire new smart contract address in order to interact with our application. We made inside the changes the bug fixing, and for our users, they will be able to keep interacting with the same contract address, which is the proxy address. And that's it. This is how you can use upgradable smart contracts. And by the way, you now have a pretty template you can use for any of your crowdfunding campaigns if you want to take this project and take it to the next level. And that was it for today's tutorial. Don't forget, all the code for this lesson is on the GitHub repo, so check out the link on the description. And as you are already here, click over here to subscribe to Moralis channel, turn on the notifications, and also check out more videos. Thanks for watching till the end, and see you on the next occasion.